Hey, hello there. Hey, hello there. Oh, it's too fucking loud. Why? Maybe I gotta move the microphone. Wait a sec. Um, Hi. It should definitely work. Um, yeah. Um, Hi. It should definitely work. Um, yeah. Um, Hi. It should. Shit, it's really too loud. Definitely work. Shit, it's really too loud. Definitely work. Shit, it's really okay. So now I'll try talking like right into the microphone, and I hope I'll get some viewers. So I haven't. Oh shit! Shut up. Sorry. I haven't. I don't think I. Oh yeah, I have some streams. I've had some streams, and now I thought, well, I'm uh, uh, yeah, I'm about to finish my school. So, yeah. Well, so I'll start, and maybe you'll learn something, something cool, something new. So the first thing we're gonna do is we'll write the malware client as it is, and well, first of all, yeah, we're gonna do some. Um, we're gonna create a main file. Let's call it just how should we call it? Main core maybe core.cpp, and it will be enough. So let's just test whether it works. Yep, thank you. Yeah. Let's see whether it works, and it definitely should work. Wait, I mean, why shouldn't it? Yeah, we have hello world. Now we're going to do some thing. Well, we gotta change the settings. So the thing is, while C++ is being compiled, it's dynamic. The Visual Studio in the C++ itself uses dynamic compilation by default, and so this is why, for example, we have to. And normally, if I would just distribute the software, we will have to distribute also Visual C++.dll and a bunch of files with it, and which is in case of remote access tool, remote administration tool, there are two names for RAT. Well, I prefer remote access tool. So, excuse me, I'm about to sneeze. Sorry. Which is in case of any malware, and you can see the disclaimer. Please do not use the knowledge for illegal purposes, and yeah. So in our case, we won't be able to just deliver all the necessary DLL files. So what we're gonna be using is the so-called static linking. So everything, all the DLLs, etc., 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 are compiled into the into the binary. Well, the binary has a much larger size, but first of all, because it's C++, it doesn't even matter. Well, it does, but because it's C++, it will be reduced and optimized by compiler or all the libraries, and the size won't be as big as, for example, .NET or any other compiled or runtime languages. Yeah. So yeah, again, it's C++. It will work, just because it is. So code generation, we gotta do the multi-threaded debug, the multi-threaded. We gotta choose like this, multi-threaded MT. Apply. Okay. So now we have to select the release, and we'll be working in the release mode, right? Did I receive a call? Oh, I just received a notification from YouTube. Now live on YouTube. Oh, thank you. I didn't know I was streaming. So let's save it and recompile. Yeah, it works, and so you can just compare. How much memory it takes, how much memory C++ takes. Well, this isn't a program at all with just one empty for loop running, but 600 kilobyte. This is much less than a .NET runtime would take. So this is definitely what we want to achieve. The thing is, we'll use the boost library to to open the socket. To use the sockets, we will of course, we could use the WinSocks etc. But for me, WinSocks, I do understand how Unix sockets are working. I do more or less understand how boost sockets, boost SIO works, but I have no goddamn clue how WinSock works. Well, I tried to make it work, but yeah, it wasn't the best coding experience as it is. So yeah, let's go for boost. And the first thing we'll be coding today is the it will be the reverse shell, right? So first we'll do a reverse shell, and well, yeah, but now I'm thinking like it's I don't want to write the server, the attacker server today. Oh shit. So what should we do? I don't want to write the attacker server today, but I think this is the only. Yeah. Well, I don't think would. I don't know. Let's give it a try. We'll just start writing, and we will see, and we'll see later. So, oops. Oh no, I didn't want. Oh yeah, I wanted to open the terminal, and in Kali Linux it's just Control T. So, yeah. No. YouTube just. It says excellent connection, but there's trouble loading. So. Yeah. Let's. Where is this thing? I'll be using VC pack. Pack. Oh yeah. So with this command, pack integrate install. Oh, this is the wrong one. Sorry. Oh no, not integrate. Install integrate project. So if I just write project M, install package, build systems. Yep. So now we have to view. No, analyze test. Where's this shit? Sorry. Analyze debug build project. We have to manage muted packages. Now we oh, package manager console. There it is. So like we have paste inside and here we go. It should work now. If I'm include foo/hpp. Hello? Hello there. Yeah. So now I hit compile. Yep, it did work. Also, wait. For my oh no, I don't know why my computer is. My PC is pretty loud now, but I don't know why, because it shouldn't be. It shouldn't be a problem at all. So purpuses.hpp. What we're going to do next is create. We're gonna create some data structures, and I'll tell you what the problem with all these data structures is. So now let's create a new item, let's create a new header file, and let's call it data, like just data. So we're creating, like, for example, we want to transmit any data, right? And we want to transmit some data, and to do it will be, well, what's the best way to transmit the data? Well, create a structure, cast it to bytes, send the bytes over the socket to the server, and let the server decast, like convert the bytes back to the structure or to class, to object, whatever you want. So yes, and it is the best way, but the first problem appears we'll have multiple data structures. So what is the best way for server to know how to, well, the thing is, the server just receives, for example, 2,000 bytes of data, and it doesn't know what to which data structure it is. Well, it could try to figure it out, but it won't be the easiest algorithm to implement. So much more easier thing is to create a structure, a packet structure, which will contain the bytes of which will describe the type of packet, of package, and the network package, and and have all its contents as a byte, as a byte array. So let me show you so you can see it, because my English it's a horror right now. So type def let's call it network. Let's go like that. So what we're gonna save here is integer and packet type. So the first, I think, 4 bytes of the packet is always a packet type. The type of the packet itself. So when the server receives it and parses the four first bytes, it instantly the server instantly knows, hey, what type it is. So I would also write int the data size. So I don't think we will be actually using the data size, but it's good. It's very practical to have this kind of field, which is also fixed 4 bytes, right? So we can definitely know the server instantly knows the first 4 bytes of is packet type. The second 4 bytes are data size, and the rest is char character data, and the rest are just the bytes. So you didn't get it, right? So if we have an instruction which we want to send to the server, we won't be sending it like instantly. We won't convert it to bytes and send instantly, because the server will have a hard time decoding it and figuring out what it is. So what we're gonna do is we will cast the structure we have to bytes, get its size, and create a new structure packet with defined packet type. We'll count the bytes of the structure we want to transmit, and write it here, and the bytes of the structure itself will be written here, and then we will cast the whole thing to the bytes and send it to server. So when server receives any bytes, right, it will instantly know, that's decoded, and it will know, this is the first 4 bytes are packet type, and the first 8 bytes are packet type and data size. It will automatically decode it and say, this packet, this and that packet packet should look like this and that. So first 4 bytes of the data are maybe first byte is a bool, the second then 4 bytes of integer, etc., etc. So the server will instantly know how to decode it, and it will run much faster and much better. So yeah, so type of struct. So the next structure we're going to create is the handshake structure. Basically the device information. The device will the victim's computer will send data about itself to the server, and so the server can knows what kind of PC it is, etc. Yep, that's the wrong thing. And handshake. So let's create first this pool is pool is running admin. So next we have to transmit, and now this second thing comes. A while ago, I think 2 years ago, I tried to make a mesh network messenger, which you use the Qt framework, and which you could run on your device, and which ran on which ran on C++, which I wrote in C++, and which ran on your device. And the thing is, I had a problem because I, for some reason, I couldn't transmit any string, and I thought, hey, why? Because don't forget, I'm now finishing my school. I'm now finishing the high school, and I have never learned programming or coding or any computer science stuff. The whole thing I figured that out myself. So I was like, what the fuck? Why doesn't it just can't it just work? Why can't I transmit the string? And well, then somebody told me, oh, there isn't actually there are no strings in C++, C++ at least. There are the arrays of pointers and back to pointer, letter, and with the pointer on the character, and the pointer to the next character. And this is basically, the whole thing is wrapped to an abstraction of kind, and the abstraction of the whole thing is basically the string, and this is what I basically figured out, that you can't send. That would be wrong, and you may be asking why, because it's character, so. Also std string computer, let's take computer name. It would be wrong because the std string is basically a abstraction, a high level abstraction for character, and what you can see is this is the pointer symbol. And why doesn't it work with pointers? Because the thing is, maybe I gotta draw. Let's give it a try. Maybe I'll. Ooh. Yeah, the thing is, let's imagine we have two PCs, personal computers, too. Yeah. Where is this? The it's here. Oh, what is the film? Stroke. Let's imagine PC1 and PC2. So. I have to draw the hands. Anyway, let's imagine. Well, yeah, let's imagine there's a space for a program for let's take client program, which is this is a memory. And this is the memory. This is the memory and this is the memory. Two different PCs. So and the program starts, and the operating system just allocates the memory for program to run, which is here. There's code memory, etc. So this is the other program. So of course there's virtual memory. There are address and memory spaces. So but I won't explain it because it's too hard and it's not related to the current topic. So and let's imagine there's a pointer. there is some line of code which works with a pointer and to this address of memory. Well, yeah, let's not overcomplicate it, right? So doesn't matter from where, but if I access this address, if I try to access this address from the program within, let's 0x 0 times 0, 100, any address, right? So if I try to access it from here, it will work. I'll try to access which is basically a pointer. So, and we have this pointer to the address, we have here a pointer to the address, etc. So I'll try to access the address, and by using the pointers, I'm basically telling access the address, not by using the pointers, I'm basically telling, well, access this address. So, and how the string, the basic this character string works is, as you can see, char is it's just a letter. It's just a character. So how this high would actually look like in memory is so these three characters are actually there should be termination character at the end, but we'll leave it out now. Oh, it looks like hard. Yeah, so this is basically an H, and this is the let's yeah, well, imagine these are the memory addresses, and this high is actually the H, and after the H, after the character H, there's a pointer which points to the address of I, and in the this pointer, this is why you can, for example, if you use the bare C, right, you can't like just compare or set these characters, the strings as character pointer. So you can just you have to use the function string copy, string compare, etc. You can't if you'll try to compare them to two exact same strings, it won't, the statement won't be true, because you're actually not comparing not the letters and the string itself, but memory addresses, and it can be just, well, the same address, right? So yeah, so you see why what's the problem with all the strings, right? And it's nice, and as I've already mentioned, you can access the content the content of this memory address by basically from any or nearly any point of your program, or, well, I think any point of your program within the allocated memory. But again, the thing is, and it won't be a problem. At least you won't. At least you don't transmit to another system. And in this case, it's the server computer. And this is where the thing gets a bit harder. Well, it was for me, but now it's since I do understand the whole thing, how the whole thing works more or less. Yeah. So wait, I gotta check my phone. Wait, is this actually this video on my channel? Holy shit. Am I even live? Yeah, well, I am live, but anyway. So when I try to, or if I say like convert on some way, on some kind of, if I try to transmit the string high in this case, so let's pick a color. Yeah. What if I try to? Try to take this high and transmit to the other. Let's imagine we have a new process running here. Let's imagine, because on every PC memory allocation works, the memory is allocated a bit differently, not algorithmically, but well, there's a memory, and the addresses would change anytime you rerun the program, right? So, well, you could do shared memory in well, at least in Linux, but this is not. But let's imagine there's a firewall or something, well, or something between, so you can just do the shared memory between these two PCs. These are totally different pieces, and let's say this is Windows, this is Unix, or yeah, it's and say the memory is allocated just like there, and to make it more easier, here's the allocated memory, and we have the server application. But the memory is allocated on the other side of the RAM, and this is more. There are some more programs working here in the memory, etc. It's not the point. So then we just say, oh well, we'll transmit the high to this machine, to the server. Will it work? Well, at the beginning, yeah, it will. So we will. So when we transmit the high, it will say, "Oh, yeah, I received something," and this is the. But the thing is, it won't receive the high. It will receive the only thing it will receive H, and then pointer to 0x11, right? Or 0x11, or like let's say it will receive the pointer 0 times 11. I don't know how it's like how memory addresses are pronounced in English. So to this memory address. And this program was, there's an H, right? This is the first character, and the other character is this location. And it will say, oh, right, I will try to access exactly this memory location. So I'll try to access this memory, which is wrong, which is not allocated. Or, well, since each program has its own memory, virtual memory space, etc., it's more complicated than that. But yeah, I think you got the idea, right? So it's you could basically, yeah, you can just share, like, transmit a pointer, right? And it won't work. You can just transmit the only letter, but you can again you can transmit the strings because of the undefined size. The complicated thing, why you can transmit the integer or boolean, but you can transmit the string, because integer is fixed to 4 bytes, right? Normal unsigned integer, I think, is fixed to the size of the normal unsigned bit. Unsigned int integer is fixed to 4 bytes. I think boolean is, I think it's just 1 byte, but it's I think boolean is only 1 byte. Yeah, but string, how large is it? Is it pointers? Well, how? And this is a problem behind transmitting strings. So what I want to tell is, what we're going to be doing is, of course, we will transmit the string. We will transmit the array of characters, but in this case, we'll just say, well, shit happens. We'll transmit or only the sound, only well, is the fixed size of characters. So yeah, for example, let's say we'll be computer name 26. It's too large. Let's say so 32. That would be more. That's more than enough. So now we say, yeah, we'll transmit. We'll allocate and exactly enough memory for this computer name, right? And we'll know for sure how much memory allocated, and we'll also, instead of using the pointers, now we do not use the pointer. Now it's the letters we transmit are basically separated from each other, but basically in the same array. So with this code will just solve the problem. So character username, character username, character OS, let's see, OS name, so language, username, OS name. Okay, and then the executable path. So yeah. This is the whole thing. Right, and this is what we'll call a handshake. So process name. Oh no, let's use it for now. Let's type. Well, let's create a function which converts. Oh, I'll let GitHub Copilot do it for me. Converts package to include we'll be using vectors to vector of characters with a point. Well, this is not the right well, let's give it a try. Well, it looks like handling it as a character. Well, character is in this case character. I know it's confusing, but it's not a character. The char it's a byte in this case. I don't think we can actually use byte. Oh, well, we can. Right? Not a deal. Not a big deal. And let's create a vector to packet to jar one vector. I don't think this code will work. I don't think this code will work, but again, let's give it a try. Handshake vector. I don't know. No. Now we have to do the code. Packet. Handshake. It won't work. It definitely won't work. Because just handling the pointer to a handshake is huh? Since when does it work? Because I don't think it does. I really don't think it does. Okay. Right? If well, the AI is I think it's much more smarter. It's much smarter than I. So I'm gonna check Discord. So I got to check Discord. So we'll have to rewrite the code ourselves. Yeah, definitely. Definitely won't work. But again, let's let it be for now. Files. Okay, let's keep it in a header file. Manager. Now include the Windows page with IOStream string vector. Well, yeah. No, that's fine. Wait. String get executable path. Well, I'm not sure whether it will work or not, but yeah, buffer max path. Well, it should work, but I don't think it will. But, yeah. Shit. Get executable path. It's core. Oh, yeah. I forgot to include it. I also don't think it will work. Yeah, C, well, it only gets the first layer of the executable path. So basically it does not work. No. Yeah, I still don't have any viewers. Buffer overall, well, we're right with the buffer. Shit. But I think it has something to do with the, yeah, I don't think this is because of the size of buffer, but because of the size of the LP, the string. Well, this will maybe work. Yeah, oh, it's a person. Yeah, it did, definitely did. Well, I know you can see it because of the disclaimer, but there was some strange. I think this is something. This is something. This is what this thing. It imports some warnings, but yeah. Again, as long as it works, don't touch it. The first rule of every programmer. As long as it works, do not then touch it. And the thing doesn't work again. Huh? Why am I streaming in HD? I installed a new cable internet connection. I'm paying like, I don't know, like 40 years a month now for a 50 megs upload, which is more than enough to stream in full HD or even 2K. But yeah, why? I think I forgot to I'm afraid I forgot to reprogram the video output scaled. What the shit? It should work. It says output scale to full HD, but it's not. It's or maybe it's just because of YouTube. Well, it wants to with the encoder decoder, and it wants to make the work easier. So yeah. So, yeah. let's go for 256. And let's check whether it works or not. Max. Oh, well, it well, did work. So here, the end line. Get username. Oh no, I don't know to get the. Sorry. Oh, someone's watching me, but I think it's me. It's me because I opened the whole thing on into different windows. So yeah. So STP get executable path, get username. Data. So we have the computer name with, oh no, we haven't. STD get computer name. And this should also work. Desktop, yeah, it does. Get the username, get OS name. Well, I don't know. Isn't it the same code? It is the same code. It is definitely the same code, exactly the same. Get OS name. Yeah, it is. So, wait. GitHub Copilot fucked up. Sorry. Get OS name. Get OS name from registry. Oh. Let's start to get the name from the registry. Oh, Windows 10 Pro. Oh yeah, it did work. Oh, why? Guys, as you can see, you can all these AIs, the ChatGPT, which I'll be using, which I do use and I will be using for this, let's call it project, right? ChatGPT, the whole GitHub Copilot, etc., etc., etc. It's very good, right? It can replace a lot of knowledge and a lot of researching, right? But it cannot replace a programmer. So without me knowing the whole thing, it would be just useless. It won't be able to generate a proper code without me knowing what this code does and what it does wrong and what is the best way to implement it. It can, so this is what I like about the AI. It doesn't replace the person itself. It only does replace, like, it's like a calculator, right? Many years ago, people had to calculate all the things themselves, but then the calculator was created, and people can focus on bigger things, on ideas themselves, and didn't lose the focus by doing some uninteresting things. Well, it's not interesting to write this thing, and it's very it's very annoying to write all these things myself. Well, it would be for me, right? But if AI does that, it's just awesome. For example, in here in Austria in math, we do use first of all we do use calculators since we're 14. We do use calculators, especially for our tests, for our math tests. We do well now. We do in the higher forms. We do use PCs. Yeah, we do use PCs, and we do use GeoGebra. This is the math software to draw the graphs, to automatically calculate a lot of stuff, etc. So it does the thing much easier, right? We also do have a formula collection, so it's like a small book we actually have to use for our test, which is where all formulas and are well listed, and which formula does what, etc. So, and it's well basically all the knowledge all the things we have to learn. We can legally see these things. We can legally use PCs while the test, but there's still bad grades, and you have to think yourself, right? You have to come up with an idea how to solve this and that problem. This is, for example, why you can't really cheat. You can't, because first of all you don't know the I forgot the word. The assignment. You don't know the assignments you'll get, but and you don't know the assignment you'll get, but the cheating makes no sense, because you get the formula collection, you'll get the calculator, you can use the PC to calculate as to make to solve the equations really fast with one command, and it makes basically impossible to cheat, and it makes people really and I have to, and we have to really think and come up with ideas. So it's pretty nice, and I think the ChatGPT and Copilot are the same thing. It can do the thing much easier, but if you can't, but if you don't understand the thing, it doesn't help at all. You have to understand it. And I've met one guy. One guy I know. He tries to learn Python, and what he did is basically to write into the ChatGPT, create this, create that, and try to combine and manipulate the code that ChatGPT wrote for him. And on the one hand, it's good to see how the code should look like, but on the other hand, me, for example, I had to learn it myself. I had to figure it out myself. Back then there was no ChatGPT, there was no GitHub Copilot. There were just books and some YouTube videos, and that's how I learned it. And this is why I'm capable of writing the thing now, and without any without any algorithmic help. So, again, AIs help me, but not the help. So it takes me work, but it doesn't really help. This is much better. So with this code, for example, I think it won't work. It doesn't look like it will for me, because I'm familiar with such a things, and they should look different in C++. It's definitely a language. Yeah. 0409. Huh? Is this a language? Well, it didn't work. But install language or keypad it. Huh? Why didn't it work? Why didn't it go to work? Look, query. It's the same code, is it? Well, maybe this is the only the number of language. Wait. Oh yeah, it's this is the yeah it does actually work, because 0409 means English United States. Well, country code. Yep, this is the thing we want. Now I think it's the same again. Yeah, it is the same. So yeah, there is a Windows API function, I think. Yeah. This is it. This is it. I see. Well, without knowing that there is a Win API function, I wouldn't like. It would work. I wouldn't see there is such a thing. So now it works. The next thing is net global. Oh, no, wait, get global clipboard data, text, let's copy it. Is double string, yes, it works. And also let's get a std string get give window title bullet complete. Window title get workout window. Window title. Oh, actually, yeah. This is the this was the active Windows title, but the program exited instantly, so it changed it to window title here, but it remained here. So yeah, this is the clipboard. So the last thing we're gonna do today, because I'm tired and there are no views at all, so I will end the stream soon. So I'm streaming for about an hour. Yeah. We're gonna be doing this. We'll create one more data structure, which will be. Oh yeah. No, we will. String. System time. Does it work? Yeah, it will. Oh yeah, it works. The system time. It works. So type struct screen. So what screen? Well, we'll do the screen transmission a bit later, but screen. Struct screens. Polling, let's call it polling package or keep alive. Window title, clipboard text, and system time. Oh yeah, it automatically. Well, package packet. Include manager. Package. Oh, we didn't do it. Like, let's just pause for now. Because it's actually much more complicated than it looks. String copy as I think it should be unsigned. Okay, make handshake. Calling package to package. Package. Doesn't actually string copy string CPY as safely. Doesn't it require one more overload with the number of maximum letters? I think, isn't it like here? Should it like around? Like this. Or silent bytes, but yeah, it's should. Where do you got that? Yes. Oh no, the Microsoft docs are always pretty good. There's a shit written about the commands themselves, what they do. Routine required header. Well, yeah, but huh? There's, for example, count of string buffer. Why? There is no overload. Otherwise, I would get an error. And there are no unsigned. Oh yeah, because of course, yeah, because I copied the unsigned, right? And there is no it's definitely no overload. Oh, so maybe when you use building C++ code, this template version may be easier to use. Yeah, so maybe it figures it out itself automatically how much we have to copy. It's not a problem at all. So yeah, that's for today. It was it. Thanks for watching. If someone's watching it later, maybe, and yeah, we'll see you. I'll see you